All right, so for the third time, today we're going to be covering what are known as third roots, fourth roots, and fifth roots. And you already have some experience, more specifically, with what are called square roots. So what we're going to do today is start off with something very basic, like naming things and understanding what things are and how to call them. And then we're going to build on it, so hopefully today it doesn't feel like you're starting something new, but building on something old. So let's start with what are powers. And powers are really just a fancy word of saying exponents. And if I have something like a squared, this is just telling me that I have a base. My base in the situation is a. I am multiplying my base by itself 2 times. So if I were to write this out in factor form, this would be the same thing as a times a. Because again, a squared is literally just telling you to multiply the base by itself twice. Now let's say if I would have started with a squared, and I'm trying to undo that square. Remember, an exponent tells you to multiply something that many times. What would be the opposite operation of a square? You guys remember? Yeah. Yeah, I always do that little sign too. I like to call it a wannabe check mark. And that is what is called a square root. A square root is telling you to find something that multiplies itself to equal the inside. So what it really does, it works backwards of what powers do. A square and a square root cancel out. So if you have something like a squared, a is multiplying itself twice. What multiplies itself twice? It'd be just a, right? So keep in mind here that a is the square root of a squared. Now let's choose a number to make it make a little more sense. Let's say I have the number 81. And for some reason, I want to come up with a number that multiplies itself to equal 81. Well, what I'm really doing is finding the square root of that number. And what multiplies itself to equal 81? 9. Absolutely right. Now, keep in mind here that there's a certain naming, and I would say like kind of like a saying. 9 here, the number 9, is the square root of 81. 9 is the square root of 81 because if you take that 9 and multiply it by itself twice, it equals 81. So again, 9 is the square root of 81. So this is all kind of review. It's something that we've done. Now let's go up it up a little bit. Now notice here that I have an a to the third power. This is telling me that I'm multiplying a by itself 3 times. Now, if I am multiplying itself 3 times and I want to undo multiplying something by itself 3 times, what would I do? What would be the opposite operation? Well, it wouldn't be a square root because the square root is asking to multiply itself twice. Now, this is where things get very, very familiar because it's still going to be that little check mark. The only difference between figuring out how many times to multiply itself is that in that little crevice here, which we like to call an index, you're going to put a 3 there. A 3 is telling you to, hey, figure out a number that multiplies itself 3 times to equal the inside. Again, this little guy, the one inside the crevice, is called an index. Now, whenever you have a square root, there usually is no number there, but it's implied if nothing's there that it is a 2 because you're multiplying something by itself twice. So, a third root and a power of 3 cancel each other out, so you'll be left with whatever multiplies itself 3 times. Now let's choose a random number to kind of help this make sense, hopefully. Let's do 125. And let's say you're trying to figure out what multiplies itself to equal 125. Well, you're not just going to take the square root of it, right? You're going to take the third root of it. How do I know it's a third root? Because there's a 3 in the index, in that little crevice of the wannabe check mark, okay? Now, oh my goodness, what multiplies itself to equal 125? 5. Now let's say you didn't know that. Well, this little chart is going to help you because notice that when you look at the square, these are all the numbers that have a number that multiplies itself twice to equal that. So for instance, if you end up with 9, what multiplies itself to equal 9? 3. Now look at this list of thirds. These are all the numbers that have numbers that multiply themselves 3 times to equal this number. Now, I am looking for a number that multiplies itself 3 times to equal 125. Is there 125 in my third list? In my thirds list? Yeah, it's right over here. Because what number multiplies itself 3 times? 5. So this equals a positive 5. Now again, I don't only want you to do the math, but I want you to understand what is going on in terms of the naming or the nomenclature, so to speak. 5 is the third root of 125. Now, again, when you guys read the statement, I want you to understand two things. One, that if you multiply 5 3 times, it equals 125. If you think of the third root of 125, you're thinking of what multiplies itself 3 times to equal 125, which in that situation would be 5. So I also want you to understand the relationship among them. All right, let's do one more just to fill out this chart. Notice that we have a to the fourth, which is multiplying something by itself 4 times. Now, what would be the opposite operation of raising something to the fourth power? Fourth root. Now, again, how do we mathematically show a root or an nth root? We just write a little 4 in that crevice to pretty much tell the reader, hey, man, find something that multiplies itself 4 times. Let's just use a number just to kind of make it sense. Let's choose 81. And let's find the fourth root of 81. So on top of my head, I really don't know how multiplying numbers 3 times or 4 times. So let me use my chart. Here's my chart. Here are my fourth roots, or here are my powers of 4s. Does there exist 81 on this list? Yeah, it's right here. And what number multiplies itself 4 times? 3. So also understand to communicate the relationship between these. If I look at the fourth root of 81, it's equal to 3. That means 3 is the fourth root of 81. And this is true for no matter what. If you're multiplying something an n amount of times, whatever your heart desires, it doesn't really matter. Because if you have that a, and you take the nth root of that a, it's going to equal some number. Let's call it b. And you're able to use the naming exactly the same. B is the nth root of a, or whatever's in the inside of whatever you're taking it. And that's pretty much it. This is like kind of like the basics, and you can see that we're pretty much building off of what we know about square roots and just taking third roots and fourth roots and so forth and so forth. And today all we're really doing is simplifying these additional nth roots, so to speak. Does that make sense? Okay. So let's go ahead and start with these 4 problems. I'm going to give you guys roughly about, I don't know, 15 seconds to do these problems. So let's take 15 seconds, see if you got them, and then we'll go over them. All right, so a little bit more time than 10 seconds, but let's just go over these problems. So notice here that we're looking for the third root of 64. And more of the story here, what we're doing is we're simplifying. We're starting with something we're trying to make it look a little easier on the eyes. Now, if I'm looking for a number that multiplies itself 3 times to equal 64, this list is going to help me out. Because these are all the numbers that have something that multiplies itself 3 times to equal that number. And does 64 exist on my list? Yeah, it's right there on my third, right? And if you look at over here, what number multiplies itself 3 times? It would be a 4. So I know that this whole equals 4. This whole thing equals 4. Let's look at this. Now notice that there is no index. When there is no index, what is implied? What is there? A square or a 2. Now, why do they change it? Why do they call it a second root? I'm not sure, to tell you the truth. I'm assuming because they do a lot of it. Yeah, so what is the square root of 36? You probably don't need your list for this one. What multiplies itself twice to equal 36? 6. Absolutely right. Now, notice here that you have a square root, because we just said that there is a square in a, how would I say this? We just talked that there is a 2 inside the index when there's nothing there. Now, notice you're taking the square root of a negative 2 squared. Now, this problem is just to pretty much remind you, what does the square root and the square do? They are what? Opposites of each other. They're inverses. So notice here in this problem, these two would technically cancel out, and you'd be left with a negative 2. All right, very next one. Notice you're taking a fifth root of a negative number. Now, before you start actually figuring out what times itself 5 times equals 243, let's concentrate on a negative. Now, if we're looking for a number that multiplies itself 5 times, what is true? Does it have to be negative or positive, or can there exist a number? Or does there exist a number that multiplies itself 5 times to equal negative? Let's think about this. If we're multiplying something by itself 5 times, it's a negative times a negative times a negative times a negative times a negative. 1, 2, 3, 4, 5. What's a negative times a negative equal? Positive. So these equal a positive. These two are also going to equal a positive. So notice that you're left with one final negative. And what do you notice? What's a positive times positive? And then finally times that negative is going to get you a negative. So notice that when you have an odd amount, your final, if you're taking an odd nth root amount, you're always going to end up with a negative number. And it's kind of nice because once you put the negative there, you can just really forget about it and think of what multiplies itself 5 times to equal 243. Here's my list of 5s is 243. Yep, it's right there, which is, in this situation, a positive 3. So multiply negative 3 by itself. Five times, and you get that negative 3. All right, are you guys tired with the basics? Are you guys ready to up it up a little bit? All right, so what do you guys notice about these that were not true about all the other ones? Notice here that when you're trying to take the square root of 32, you're really trying to think of a number that multiplies itself to equal 32. And if you look at your list of squares, does 32 exist on this list? Not of squares, right? So remember, how in the world am I going to simplify this? Now remember about 6 months ago when we did a whole bunch of these? Do you remember it like it was yesterday? No, well, I'll pretend and I'll kind of review at the same time. Remember that when you, in order to simplify a radical, and for whatever radical it is, if you don't have a perfect square or you're not taking a square root of a perfect square, what you want to do is look at your list of squares and ask yourself which one of these numbers can be rewritten as a product of a number and some other number to equal 32, aka which one of these numbers multiplies to 32? Does any of them stand out? Yeah, because 16 times what is 32? This is the same thing as 16 times 2. Now remember the property that if you're taking the radical of two products, you could actually take the radical of both of those products or those factors right away. And what is the square root of 16? 4. Now can you take the square root of 2? No, so that means that this here is your final most simplified form. Now some students would argue that, does this really look any simpler? I wouldn't argue no, but again, mathematically we need something to agree on, and that would be is to make sure that there's nothing underneath the radical that can be rewritten as a product of a perfect power or something along those lines there. All right, so let's do one with the 3 just to make sure we got it here. So I'm going to let you guys do the number 3, give you guys about 20 seconds, and then we'll go from there. All right, so let's go over these problems right over here. So notice you're trying to take the third root of 32, but unfortunately for us, if we look at all our third power, there is no 32. So unfortunately, we can't simplify it to be a whole number. But can we rewrite 32 as a product of one of these? And the answer would be yes, right? Because 8 times 4 is 32. So this could be rewritten as the third root of 8 times 4. Now, this is the way I like to do them. I'm not going to force you guys to separate them, but I am going to have you guys write down the two products. Now, if you were to take the third root of 8, what would that operation come out to be? What's the answer? 2. Now, a 2 comes out of the third root. Now, notice you cannot take the third root of 4 because it doesn't exist a whole number that multiplies itself 3 times to equal 4. So that stays in. And you always have to go back and check. Be like, okay, I'm taking the third root of 4. Here's my third roots. Is 4 on this list? No. Can I rewrite it as a multiple of a number in this list? No as well. So that means you're as simplified as possible. All right, third root of a negative 54. Now again, you're taking an odd root of a negative number. What is true about your solution? It has to be negative because you need that third negative in order to make it a negative, right? Now is 54 on our list of thirds? No, but can we rewrite it as a product? Yep, 27 and 2, because 27 times 2 is 54. don't forget that this is all still underneath the radical. All you really did is rewrite that 54 as 27 times 2. Now, what is the third root of 27? 3. Now, what is the third root of 2? It's some type of decimal. We don't want decimals, we want whole numbers. And that's pretty much about it. All right, so this is pretty much a numerical answer to pretty much help us figure out how we're going to do nth roots of variables. Now, notice here that I am taking the square root of 2 to the 5th. So what would this simplify to? What do you guys think? 2 to the what? What times itself equals 2 to the 5th? Well, let's write this out. If I was trying to take the second root, or the square root of 2 to the 5th, how many times are you multiplying 2 underneath that radical? I believe it would be 5 times because the exponent is 5. Now let's think about this. I'm looking for something that multiplies itself twice. How many times is 2 multiplying itself? 2 times. So if you have 2 groups of 2, that's the same thing as 2 squared. Now keep in mind that, yeah, these are 2 groups, but this little 2 out here is a loner, so it's going to stay in the inside. And let's simplify this because we know what 2 squared is. What is 2 squared? Now, I don't know about you, but I don't want to have to expand these out each time, count the groups, and do all that. I want a way to be able to figure this out just from the start. And let's figure this out together. Remember that what you're really doing here is you're figuring out how many groups of 2 you have in the inside. So when you have something raised to an exponent, all you have to do is ask yourself, how many times does 2 go into 5? And how much times would that be? How many times would it go in? 2 times what is close to 5? Or how many times does 2 go into 5? 2, right? So that's why a 2 squared comes out. We know that 2 squared is 4. Now keep in mind that if 2 goes into 5 2 times, that is 2 times 2, which is 4. You're left with 1 over, so you're going to be left with 1 in the inside. Okay? Now, why in the world did I spend so much time doing that? Because, again, we're going to start doing variables. If I tell you to find the square root of x to the 4, I'm asking you to find the second root. How many times does 2 go into 4? Twice. So this just simplifies to x squared. That's it. How many times does 5 go into 10? Twice. So you end up with x to the 2, which makes sense because if you multiply x to the 2 5 times, you're going to have it multiplying itself 10 times. Again, you're just coming with how many groups of 5 do you have in 10 things, really? Because you're looking for stuff to repeat in multiplication. All right, how many times does 3 go into 9? 3, so it's y to the 3. Square root of 9. How many times does 2 go into 9? 4, so it's a to the 4. Now keep in mind that there was a loner left in the back, so it has to stay within the square root. Now, one thing I do have to make sure that you guys watch out for is that if you have a square root and you don't include the 2 in your index with your answer, I'm not going to mind. But if you do that, same thing with a third, unfortunately, you will be marked wrong. And I'll show you what that looks like in a second. So how many times does 3 go into 13? 4. So you end up with y to the 4. Now keep in mind that there is 1 left over because 3 times 4 is 12, and there's 1 left over. And this is what I mean, that unfortunately I would have to mark you wrong because a square root is not the same thing as a cube root or a third root, so you have to make sure to have that third written there. All right, so tricky but not so tricky once you see it. Notice you're taking the square root of this monstrosity to the 8th power. What is multiplying itself over and over again? Y squared plus 2. Now, how many groups of 2 do you have that's repeated multiplying itself? How many times does 2 go into 4? Oh, man. How many times does 2 go into 8? 4. Now, what is multiplying itself over and over? It's y2 plus 1. So don't forget, it becomes y raised to 2 plus 2 raised to the 4. Cool? All right, so we'll do just these 2 more examples and we'll call it a day after that. Now, what I did there is I purposely put numbers or simplifying with numbers, and then I went to variables and now I'm putting it all together. And the main reason why is because you treat them differently, but now that you know both processes, you're doing the same within a problem. Notice you're taking the square root of 25. Now, what is the square root of 25? 5, absolutely right. Now, what is the square root of x to the 4th? How many times does 2 go into 4? X to the 2nd, yep. That's it. Now notice that we have a lot of things going on, but we're just going to take our time. We're taking the 5th root of all this stuff. You know that the 5th root of 32, does there exist a number that multiplies itself 5 times to equal 32? I don't know. Let me check my chart. Yeah, it's 2. So you know that the 5th root of 32 is 2. What is the 5th root of x to the 15? X to the 3. And of course, the 5th root of y to the 20 would be y to the 4, because there are 4 groups of 5 into 20. All right, trick question here, not really tricky, but what is the square root of a negative 9? Can you take an even root of a negative number? Is there any way in the real number system that you could multiply something by itself, or really an even amount of times, and end up with a negative? No, so this is what is called a no solution. You can say no solution, you can say complex, you can say pretty much anything that just pretty much allows me to get the idea that you know that you can't pretty much find a number that multiplies itself that many times and end up with a negative. So yeah. Last but not least, just to finish it off, taking the square root of 81, y to the 6. What's the square root of 81? 9. And what is the square root of y to the 6? Y to the 3. And that's it.